Welcome to the chapter on electronic measurements. Understanding how to use measurement tools is crucial for electronics engineering. In this chapter, we will cover oscilloscopes, multimeters, and signal generators, which are essential tools for electronic measurements. An oscilloscope is an electronic test instrument that allows the observation of constantly varying signal voltages. It usually displays these as a two-dimensional plot of one or more signals as a function of time. The basic components of an oscilloscope include the display, which shows the signal waveform, the vertical system that controls the amplitude of the signal, the horizontal system that controls the time base or sweep of the signal, and the trigger system that stabilizes repetitive waveforms and allows the capture of single-shot waveforms. To use an oscilloscope, first connect the probe to the signal source. Then, set the vertical scale by adjusting the volts per division to fit the signal on the screen. Next, set the horizontal scale by adjusting the time per division to display the signal's period. Finally, adjust the trigger to stabilize the waveform for a clear view. For example, to measure a 1 kHz sine wave signal with a peak voltage of 5 volts, connect the probe to the signal generator output. Set the vertical scale to 1 volt per division, the horizontal scale to 1 millisecond per division, and adjust the trigger to the midpoint of the signal amplitude. A multimeter is a versatile instrument used to measure voltage, current, and resistance. It can be either analog or digital. The basic functions of a multimeter include voltage measurement, where it acts as a voltmeter to measure the potential difference between 2 points, current measurement, where it acts as an ammeter to measure the flow of electric charge, and resistance measurement, where it acts as an ohm meter to measure the opposition to current flow. To use a multimeter, first select the measurement type, whether it's voltage, current, or resistance. Then, connect the probes to the circuit and read the measurement on the display. For example, to measure the resistance of a resistor, set the multimeter to the resistance measurement mode, denoted by the ohm symbol. Connect the probes to either end of the resistor and observe the resistance value on the display. A signal generator is an electronic device that generates repeating or non-repeating electronic signals. It is used for testing and designing circuits. There are different types of signal generators. Function generators produce various waveforms such as sine, square, and triangle waves. RF signal generators generate high-frequency signals for radio frequency applications. Pulse generators create pulses with specific width and frequency. To use a signal generator, first select the desired waveform type, such as a sine wave. Then, set the frequency to the required value and adjust the amplitude to the desired level. Finally, connect the output to the circuit under test. For example, to generate a 1 kHz sine wave with a peak-to-peak voltage of 10 volts, set the signal generator to produce a sine wave. Adjust the frequency to 1 kHz and the amplitude to 10 volts peak-to-peak. Then connect the output to the input of the circuit. In summary, understanding how to use oscilloscopes, multimeters, and signal generators is fundamental for electronics engineering. These tools allow engineers to measure and analyze various electrical parameters, ensuring proper functionality and performance of electronic circuits.